Hello everyone. Our today's topic is X-rays. X-rays is one of the most known kind of radiations. In the medical applications, X-rays are very important. We all know that we have to perform X-rays for checking any kind of cracked bones or this kind of thing. But the question appears, what is this X-ray? Means, what do we know about them? We all know that there are electromagnetic waves. Even light we see every day, a visible light is also an electromagnetic wave. Clear? So there are various kind of electromagnetic waves like gamma rays, X-rays, ultraviolet rays, visible rays, the visible lights which you can see, infrared, radio waves, microwaves, and so on. Our target is to study about them, these X-rays. This is our subject as kind of electromagnetic radiation. This X-ray was invented by German scientist Röntgen. Röntgen invented the X-ray when in 1895. He was working with fast moving cathode rays. He was working with very fast moving cathode rays. Cathode rays means the electrons coming out of the cathode. These fast moving cathode rays, when strike a metal piece, a strong piece of metal, Röntgen find out that they are producing a different kind of radiation. A different kind of radiation is coming out of the metal when the fast moving cathode rays are hitting them. These radiations are mostly invisible. We cannot see them with our naked eye. But these radiations are present because we can see they can affect the photographic plate. Means if you keep a photographic plate in that place, you will find out that they are creating some effect there. These rays had very specific natures at those times which cannot be deduced by Röntgen. So their characteristics remained unknown at that time. And hence, just like we take unknown things in algebra as x, Röntgen named him X-rays. These were also called Röntgen rays as per the inventor's name. That brought him Röntgen Nobel Prize in 1901. Now, nowadays we know how to produce these X-rays and how to use them. I will ask each and every student to keep your book in front of you because we need the diagram of X-ray production. As it is very complex, we cannot draw it here. Understood? Yeah, I can show you the diagram here. This is the diagram of X-rays. I have also attached this diagram, and please watch this diagram. That will be helpful. Now, coming back to our topic, we use a Coolidge tube. The name is Coolidge tube to produce the X-rays. Now, what is this Coolidge tube? Now, this Coolidge tube is a hard glass tube, and two tubes are connected together. Two tubes are connected together inside the Coolidge tube. Let's see what does they contain. Now, the tube 1 contains the filament F. The filament F, when current is passed through this filament, it it emits thermionic electrons. What does it emit? Thermionic electrons, which are the cathode rays. And these thermionic electrons, when released, they are kept inside a negatively charged molybdenum cylinder. This negatively charged molybdenum cylinder makes them pointed in a single direction. It collimates them, because if the negative charge is there, these electrons faces repulsion from all the directions, and as a result they become more and more focused in a single direction of moving out of there. So as a result, we get from the tube 1 is a concentrated beam of electrons, and in front of this we keep the strong copper block, and in front of this at 45-degree angle we keep a very specific kind of material which has high melting point and higher atomic weight, like molybdenum, like tungsten. This T is kept at an angle of 45 degrees. When this focusedly moving, perfectly focused cathode rays moving from there, the thermionic electrons, when strike their target T, here they emit X-rays, and from here X-rays are emitted, and this is how the production of X-rays are done. But you have to be very much careful. Why? Because we need to know at which potentials usually we get X-rays. Now that production is not very easy. The filament we can see here requires a potential difference of 20,000 volt. 20,000 volt. And this potential difference is achieved by a step-up transformer. A step-up transformer helps the system, the filament, to reach that 20,000 volt value. And at this 20,000 value, they provide us a good stream of thermionic electrons. And these electrons, when strike the target T kept at an angle 45 degree, they give us X-rays, we have seen. But we have to be very much careful, because when these strong beam of electrons are hitting the target, 99.8% of the energy becomes heat, and only 0.2% of the energy becomes X-rays. So you can see here we are facing a lot of heat energy during the production of X-rays. So what we must need to do, we must keep the source cool down. Else what will happen? Yes, we are using a molybdenum or tungsten, which a material which has a high melting point, but for continuous exposure to this kind of radiation can melt them down. So to prevent from melting down, we use a cool water stream. Inside the Coolidge tube, to keep the target T at lower temperature, so that it does not melt down. Clear? One more thing we must need to be very importantly see that between the T1 tube 1 and the target T where they are striking, the electrons are coming out from here. Those electrons are coming out from here, which are focused, and target hitting the target T. In between this time, if inside the Coolidge tube, any kind of gas is present here, it might be oxygen, or nitrogen, or air is present here, then the X-ray production will not happen. The X-ray production will not happen. So we must need to be very sure that there is none of these gases. That means in between the target and the electrons, we must keep vacuum. Okay, that means that region should be devoid of any kind of air presence. And that is when the X-rays can be generated. If not so, the electrons, what will happen if we keep air here? If we keep air here, the problem is that any kind of air or gas molecules present here, any kind of air or the gas molecules present here, what will they do? Now when these thermionic electrons are coming, these ions are coming, they will collide with them. They will collide with these ions and they will lose their energy by ionizing the gas. And they will ionize the gas, and the positive ions will be attracted also present in the gas to these electron streams. As a result, the experiment will become a failure. Hence, we cannot afford to keep these gases inside there. We must need to keep the place a complete vacuum. Understood? Now, we have to be sure that what kind of X-rays are we creating and how can we control them? Now the X-rays can be controlled and can be created in two ways. We can control two things of an X-ray: the intensity and the penetration power. In these ways, the X-ray creation can be controlled. First thing first, we will first learn about the intensity and next learn about the penetration power. The first thing is intensity. What do you mean by intensity? Intensity means at how much large numbers. Means what is the amount, what is the quantity of X-rays are generated. Now this intensity of the X-rays depends on the number of electrons coming out of the filament. The more the number of electrons coming out and hit the target, more the number of X-rays produced. So if I can increase the number of electrons going there, if I can increase the number of electrons, then the amount of X-ray produced, that is the intensity of the X-rays, can be increased. And what can we do to increase the number of electrons moving? How can we increase them? The answer is very simple. If we increase the current flow. What is current flow? Current flow is the number of electrons moving per unit time. So if I can increase the current flow, this number of electrons moving can be increased. And if this number of electrons moving can be increased in the filament will give us more amount of thermionic emissions, and as a result we will get more number of X-rays, and so we can achieve higher intensity. So intensity can be controlled by controlling the current flow. This is the first kind of controllability we are looking for. The next kind of controllability we are hunting down is penetrating power. What do you mean by penetrating power? Penetrating power means just like if you are shooting a bullet and here is the metal sheet. How much can it enter inside? How much damage can it create? If that bullet can enter the large distance, we say its penetrating power is more. And if it can go to a smaller distance, we say its penetrating power is less. So penetrating power means how deep it can go. The penetrating power of the X-rays actually depends on the energy of the X-ray. The penetrating power depends on the energy of the X-ray. If I am able to produce high energy X-rays, then their penetrating power will be more. But if the X-rays are of low energy, then their penetrating power will be less. Now we all know that as X-rays are also electromagnetic waves like light, so their energy depends on the frequency. That means if I can produce X-rays of higher frequency, that means of lower wavelength. We all know that if the frequency is high, the wavelength will be low. So the X-rays with higher frequency and lower wavelength will have higher penetrating power. Will have high penetrating power will be also high. Clear? And similarly, the vice versa, if the frequency is small and wavelength, that is lambda, is large, small frequency, large wavelength means less energy, and hence the penetrating power will be low. The penetrating power will be low. So these things depends on the X-rays frequency and wavelength. X-rays frequency and wavelength. So how can we control that? Now it depends on the filament voltage or the potential difference between, is more precise than filament voltage, the potential difference between the filament F and target T. If I can increase the potential difference to a higher value, then I will have X-rays with higher energy. If I have potential difference of higher value, it will give us, that means high potential difference will give me strong X-rays. Strong X-rays means they will have high penetrating power. So we can see here that if I am providing the X-rays higher potential difference, I will get higher penetrating power. And similarly, if I am giving lower potential difference, so I will get lower potential power. Clear? Usually, the X-rays you can get from the 20,000 volt. These X-rays are quite weak. They are called soft X-rays. Usually we can also get to 1 lakh to 10 lakh voltages, and those X-rays are strong and called hard X-rays. Hard X-rays means more penetrating power. So we have got to our conclusion that two things, intensity and penetrating power, intensity depends on the current flow and penetrating power depends on the potential difference. So this much for today. On Friday we will learn further about these X-ray spectrums. Thank you. If you have any kind of doubts, you can ask me, inbox me.